Hi class, this is going to be a quick tutorial of the last task with the taxi cabs numbers 3 through 5 and the merit section. But let's just start with number 3. So I think everyone's pretty good at doing the tables. We're going to just make sure that we're putting in different numbers of kilometers to put in there. And as an example, I can go up by 1. I could also skip and go up to 10 at the end if I wanted to. So at 0 kilometers, where x equals 0, our flag fall is going to be 1.6. Then we're going to be going up by 2.4 each time. So we're going to be adding on 2.4. That should take us to 4, 6.4, and so on. So I think you guys are pretty good at that. And then we can say if x is 10, so if we go 10 kilometers, we should be going 10 times 2.4, which is going to be 24, plus 1.6 should be 25.6. This is optional, you don't have to do this, but it's a nice way to check that you understand what's happening. We then have to put in our equation. So we're going to put y equals, so y is the cost, is going to be equal to $2.4 for every kilometer, plus the $1.60 or 1.6 that we had to start with. So we're going to put those numbers in here and type them into a sentence, so it shows that we really understand what's happening in the context. $1.60. Okay. The next step is to do the graph, and it's really important that we get the hang of doing this on Desmos. So if I come into Desmos here, and all I'm going to do is I can just copy and paste it in my equation if I want. I think this should work. So here's my equation, and I kind of want to zoom in a little bit so I can see the different values. And if I go here, I want x to go up to 10. Let's go even up to 12. Let's go 15. And my y, I want to see up to, I don't know, $20. So I get a better view of what's actually happening. So now I can see, if I zoom in, my starting point is 0 and 1.6. And I'm going up every time. And I kind of get my gradient that's going across 1 and up to 0.4 each time. And there's my graph. I can then use that to answer the questions. Let me just take a quick screenshot. So I use Snipping Tool. I'm not sure what you guys have. It's a pretty good tool that just comes with Windows. I just copy that, and then I paste it in here. And my gradient is going to be 2.4. And my y-intercept was 1.6. Okay, we're going to answer the questions. The first one is, how much will the fare be if they have to travel 13.5 kilometers? So that means if they've told me that x equals 13.5, so all I have to do is replace x in the equation with that number. So it's going to be y equals 2.4 times 13.5 plus 1.6. And then I can do that on a calculator, and I should get the answer. But I want you guys to be able to do that. So it's just a matter of doing that replacement or substitution. The next question is, they now tell you that the receipt or the total cost was $13.60. So how far have they traveled? So that means we're replacing the y. So see, it's this y part here with 13.6. So we can say it's 13.6 equals 2.4 x plus 1.6. And now it's doing that step-by-step solving. So we're going to take away 1.6 from both sides, negative 1.6. That's going to tell me that 12 equals 2.4x. Then I want to divide both sides by 2.4. And I think that's going to be, I actually don't know that from the top of my head. I don't have a calculator on me at the moment. So we're going to go 12 divided by 2.4, and that will give us our x value. Okay, so that's gone through the first part. I'm going to skip ahead now. I'm going to trust that you guys can do the next two parts. I'm going to skip ahead to the merit part. So when we get to the merit part, what we're going to need is all 3 lines on Desmos. So the next one, let me just put those lines in. So for the airport taxi, it's going to be y equals 1x plus 6. So we're going to go y equals 1x plus 6. That's the airport taxi. So it's a high flag fall, but pretty cheap per kilometer. And then if I go down to the yellow cabs, it's going to be 1.2x plus 4. So y equals 1.2x plus 4. Okay, so now I can see I'm getting 3 lines on my calculator, on my Desmos, and I want to just edit this a little bit and make this go up to 16, 20. Let's go 20 here. Okay, so here are my lines. And what I can see is that these lines have points of intersection. If I click very carefully on them, it'll tell me where they intersect. Okay, so this red line, you can see that from 0 kilometers all the way up to 2 kilometers, this red line is the cheapest one. Right? But then, after that point, it's the black line that becomes cheaper. So that's this taxi company here. And that's cheaper all the way until I get up to 10 kilometers. And now it's going to be the purple company that's the cheapest company. Right? So we're getting a visual perspective of which company is the best for different distances. And that's the real merit trick, is understanding that no one company is cheapest for all distances. It depends on the distance that you're going. And we can show that writing sentences. So I'm going to say the first company, what's the red one? The red one is 2.4 plus 1.6. So that's Vodka taxi, something like that. That's cheapest between 0 and 2 kilometers. At 2 kilometers, it is the same as yellow taxi. They cost the same. But then yellow taxi is cheapest between 2 and 10 kilometers. And then from 10 kilometers on, it's going to be that airport taxi that is the cheapest. Okay. Now, the last part of the question says there's another company called Flat Rate Taxis. They charge $15 no matter what. So I'm going to type in this y equals 15. And you can see it makes a flat line all the way across. So it doesn't matter what distance you go, it costs $15. And if I zoom in here, I can click and see, okay, that means that from 9.167 kilometers onwards, they will actually be the cheapest. However, there's one more piece of information. This taxi company only travels up to 12 kilometers. So we need to stop our line at this point here. And to do that, we're going to add in these curly brackets. And we're going to say that x must be less than 12. Oh, curly bracket. And that stops that right here. If I want to be more accurate, I'm going to use a little calculator on the bottom and say it can be less than or equal to. So x can be exactly 12, but usually has to be less. So at 12 kilometers, flat rate taxis is the best. If you want to go 13 kilometers, of course, you've got to go back to yellow cabs or whichever the purple line was, the airport taxis. So you kind of get this interesting idea about using the lines to figure out which is best. So that's about all I want to go through at the moment. Please use this video, go back and forth and try use it to help complete this task. And it's really important that you have a go at understanding how to use Desmos to support you to do this. Okay, please let me know if you need any help. And that's all for today. Thanks, guys.